Welcome everybody to the Petrel birthday party. Yes, it's 20 years since Petrel came on the scene. So I'd like to take you on a trip down memory lane to see what we did and how we got here. So what was happening 20 years ago? Well, there was a couple of big companies who were very strong in seismic, companies like GeoQuest, like Landmark, and there was also companies producing reservoir simulation like Eclipse that started in 1982. But there was a gap in the middle, there was starting to emerge a gap in the middle, and this gap was modeling. And the gap in those days was filled by small companies, niche companies specializing in modeling, companies like RMS or GoCAD. And Schlumberger thought, well, it might be a good idea if we can fill that valley of death, and Petrel might be just the tool to do that. So what were we doing? Who was working on what? Well, Technoguide was a small Norwegian company started by 3 ex-employees of RMS, and they had an idea back in 1996 that they could build an integrated modeling system on a PC. That sounds not too revolutionary today, but back in those days, moving away from Unix onto a PC to try and do 3D modeling was really quite revolutionary. So there was a genius developer called Niels Fremming who set to work in his garage in '97, and he worked for a whole year, night and day. The rumors are that he broke 2 keyboards, battering away at those keys to produce the first release of Petrel. And in 1998, Petrel version 1 hit the market. So what was GeoQuest doing at the time? Well, they weren't being completely quiet. I've managed to obtain some really rare archive footage of an R&D project that was happening in GeoQuest at the time.
Here is BoxCube. We've loaded some data from ProjBox, our project store, and here we can examine the data, look at it. We can zoom in, zoom out, rotate the box around, have a look at what we have. And of course we can interpret on the cube here. We can draw fault, perhaps draw some interpretation data. It's very easy to do. Perhaps it might be beneficial to be able to take data from here and interpret it in a more general way. So we can just point at a 2D line and have the line just sent out of the data set. And so here we can perhaps use our conventional system here to interpret it. But you'll notice as I am interpreting this line outside BoxCube, real-time update of interpretation inside BoxCube. You see the interpretation updated in real time. Of our reservoir, we want to now compute some volumetrics here. So at the click of a button here, we get an instant readout of volumetrics, and that is in fact.
So you can see that GeoQuest was pretty advanced, but the Petrel boys were really getting on with the job, and they released their first Petrel software in 1998. And they had a really amazing marketing department, don't you think? Look at this, 3D, for you, on PC. Or the other catchline there, we have cutting faults, cutting tools, cutting price. Yep, they hit the market with a bang, and they started to set up in the trade shows with their little booth. They were running a bit short of money, but at the time, Shell was looking for a tool that could provide corner point gridding for their modeling package, their internal modeling package, and the head developer of that team happened upon the Technoguide stand, and as we say, the rest is history. So already in 2002, Petrel had a pretty amazing vision. Their idea was that they could have the full subsurface workflow in one package on a PC. That means starting from seismic interpretation, geological interpretation, turning that into a model, populating that model, upscaling into reservoir simulation, planning your wells, and then going through to simulation. So it was a pretty amazing vision, and it's a vision that's not really changed through the years. It's just become deeper and better through the years. This is what it looked like at the time. It was very nice 3D visualization. We have models in here, we have seismic in here, we have wells in here. Geoframe and the Schlumberger people were also busy in their own corner of the world. In 1999, some people in Schlumberger thought it might be a good idea to take their Geoframe technology to a PC. So there was a white paper called Geoframe New Technology, which resulted in a team being set up in Austin to build a product which we called at the time iGeoframe, which is an idea of capturing all of the technology that we had in the Unix world in a single PC platform. So not that much different from the Petrel vision. We rebranded this in 2002. Somebody said, you know, iGeoframe, that sounds a bit too much like a product. Let's call it Ocean, and that can never be used as a product name. As you see, things do change. So in 2002, late 2002, Schlumberger purchased Technoguide. We did a due diligence in October. We had to have a picture of Niels. He's the key developer, the man who started it all. In the beginning of 2003, end of 2002, the Schlumberger team started to arrive in the little office in Oslo to start to bring in Schlumberger technology into this product. At the time, the team from Technoguide was only 11 people. That's 8 developers and 3 domain experts. And here they all are. That was the original team, December 2002. If we were to try to take a photograph of a team today, it wouldn't really fit. There are thousands of developers on the Petrel platform. So even in that first year, in those days we used to have 2 releases, the Petrel First Edition, Petrel Second Edition. And in those 2 releases, we already started to see quite a lot of Schlumberger technology coming into the system. I won't go through the list, but key things like the convergent gridder from CPS3, the FrontSim Streamline Simulator, TST and TVT indexes, kind of high-tech functionality that really was beyond the capability of the original Technoguide team. Then a big milestone happened in 2004. We brought in the Eclipse so that a reservoir engineer could have an environment to set up an Eclipse deck, run that simulation and get the results back into Petrel. So we have really started to close that loop. It was the time for a great party. Petrel, if you're speaking in Norwegian, early is beer, so it kind of fits. We had a great party, and the reservoir engineers now had a place within the Petrel canvas. So in 2005, we started to have the full integrated loop. Now this allowed 2 key things. For the first time, you've got all of the processes in one place, and you've got a way of capturing all of those processes, of replaying those processes. We call it the workflow manager. So you could do things like keep your model up to date. When a well top changes or seismic interpretation changes, you could replay the workflow all the way through to a new volumetrics or a new reservoir simulation. And this was pretty unique because you can only really do that when you have a single system that can handle all of the different domains. It also enabled another key development, and that was uncertainty. So in 2005, we released the first uncertainty manager in Petrel. This captured the workflow, so we would build a model, capture the workflow. We could go into that model and, for example, open up the contacts and say, well, I'm not so sure of the contact, let's make that a variable. I could go into the property distribution and say, well, the net sand is unknown, let's make that a variable. We could set up the ranges for those variables, and that allowed us to loop and produce a new value of volumetrics or a new reservoir simulation for every possible instance of that model. So we were getting really advanced in the product. So you'd think in 2006 we would be finalizing some of that work. So what did we release? Anybody know? Nothing. Nothing happened in 2006. And why is that? Well, it was the start of some very big infrastructure changes. And these infrastructure changes take a large commitment and a large company like Schlumberger. This is things like coordinate systems for seismic. It's deep in your infrastructure and very hard to do and very hard to get right. The seismic scalability, to be able to scale from very small little cut down cubes of seismic to terabyte level cubes, to be able to bring these into the environment and allow people to add in their own functionality. This was the advent of Ocean. And these data sizes are getting so big that we needed to take Petrel into 64-bit. So all of these infrastructure changes were happening in the 2007 to 2011 timeframe and consumed a lot of resources, but brought many benefits. So for example, for the first time, third parties and oil companies, academia could develop their own little applications in their area of expertise and bring it into that integrated Petrel environment. So by 2012-13, you're starting to have lots of companies using Petrel, thousands of Petrel projects all over the world, and people started to say, we really need some management of this. So we came out in 13 with a product called Studio, which allowed to build a corporate data repository, if you like, for all of these Petrel projects. It means that people could then say, what data have I got available? What work's been done in this asset? They could find data. And then when they start work, you've got geologists, reservoir engineers, geophysicists all working together. They need to share their work, so they're able to collaborate via the Studio environment. And particularly in big companies, you really need the data managers to start accessing this data and looking after it, preserving the results. So that's the management, and that's what Studio brought to the table. So if you look where we were in 2002 compared to 2012, this is the process tree in Petrel, which tells you what Petrel can do. You see in 2002, it was very heavy in the modeling part. There was a little bit of seismic, a little bit of well planning. But by 2012, you've got a whole range of seismic tools available. You've got all of the modeling, which has been expanded with things like multi-point geostatistics, fracture modeling, and you've got the whole setup of reservoir simulation. So the product is getting rather complicated. So we decided we had to work on simplifying it, because we now had many icons, many processes. The real estate for actually doing your work was shrinking because of all of these processes and information from all of the different domains. So we needed to revamp the look and feel of Petrel to make it more accessible to the users. This resulted in the release of Petrel 2014, which we called our UX release. It was a release that we based very much on industry standards, so we moved to ribbons to capture all the different processes. This meant that you could have a ribbon for the geophysicist, where all the tools that the geophysicist might need were in one place. And they probably didn't need to move to other parts of Petrel. Then they could also access all of the different objects and all of the different processes, functions if you like, without leaving that environment. So for example, you might pick some seismic and make a map without having to change process, which was what you had to do before in Petrel 2013. And here we are in 2018. What are we doing now? Well, we're coming out this year with a new grid, which we call a depot grid. The idea here is that we can build complex structural models. This is what we call, in real space, the geospace. We can flatten those models into a pseudo-depositional environment, which we call depot space, build a regular grid in that depot space, and then take that grid back into the real space, allowing, for the first time, modeling and simulation of really complicated structures. So in a way, we're coming back to our roots. We've done this with a lot of people. We've got development centers that work on Petrel. Of course, in Norway, the original home in Oslo. We've got the seismic over in Stavanger, the reservoir engineering in Abingdon in the UK. We've got exploration systems in Germany. We've got the structural modeling in Montpellier. We've got Beijing doing the drilling, Houston doing infrastructure such as ocean, and we've got support centers in India, in Pune. So it's a worldwide effort to produce a massive software. So just to wrap up, I'd like to take a few minutes to think about how did we get here? What was the route to success? Well, the first thing was, of course, we had great software, which thankfully all of our customers wanted to buy. We had a vision of openness, which we can never build everything. One company can never do everything. So by being open, that allows specialist companies to bring their own technology into the system. And that vision of openness has allowed an oil company to bring their own proprietary technology into our integrated Petrel world. And the old adage of the customer is always right is very good, that you have to involve your customers if you're going to be successful. So throughout the development of Petrel, the team have been working with customers throughout the world trying to fulfill their needs and requirements, which has resulted in a constant evolution of the system. Of course, a system this big, covering so many domains, can get very complicated. So a very key pillar has been the commitment to quality, which has allowed us to produce a very robust and stable product. Finally, we couldn't do this without great people. And we've had great people in the development environment, we've had great people supporting Petrel throughout the world. And we've got a lot of great people using it. Thank you very much and enjoy the party.